And if I remember correctly, do we need to close the blinds so we can see? Is that accurate?
Yeah.
Yes? Okay, can we grab the blinds? Pull to the left. Yes, and then release. Perfect. Okay, so the first two vocabulary terms are X-intercept and Y-intercept. Those are not new to us. We've been finding those for a while. So the X-intercept is where the graph crosses the X-axis. The X-intercept is where the graph crosses the X-axis. And at the X-intercept, the Y coordinate always equals 0. So that the point is always written as x comma 0, there's some sort of number in for the x value, and then 0 for the y value. And if we were in Math 2, you would be plugging in 0 for the y coordinate, and then you would actually be solving for the x coordinate. You would be doing some sort of mathematical work for that. Since we are in Math 3 now, we're actually going to ditch that, solving by hand, and we're going to start using a calculator to find that quickly and efficiently so that we are not wasting time. Okay? So we're going to move on from doing this stuff by hand. Y-intercept, where the graph crosses the y-axis. The x always equals 0, so the point is written as 0 comma y. Same thing, if you were in Math 2, you would have plugged a 0 in for the x-coordinate. This would have been a little bit easier than finding the x-intercept, because typically the y value was already isolated, and so you just plug 0 in for x, you'd simplify the numbers, and you'd get an answer. So, for example 7, this one we can look at the graph that's already there, and we can probably recognize what the x and the y-intercepts are because the numbers are pretty nice. So can you guys see what the x-intercepts are just by looking at the graph? 2 and -6. So x-intercepts there. So I'm going to write them like points. They didn't say solve for x, they said x-intercept, so those are points. -6, 0, 2, 0. And then the y-intercept is 2. 0, 2. Okay. Example 8, I purposefully made it an equation that we would not be able to see what they are just by looking at the graph. I made it one we would have to plug into a calculator. So what we're going to do is we're going to grab those graphing calculators. And just to practice clearing them, anyone know how to clear a graphing calculator? Yes. You hit the second button, second, then the plus sign, then the number 7, then the number 1, and then the number 2. Second, plus 7, 1, 2. So if you ever have an issue with a calculator, like it's not doing what it is supposed to, it's not working the way it should, just hit second plus 7, 1, 2. That'll reset the calculator, and then you just try to do the calculation you were doing again, and usually it will work the second time. So anytime a student is like, Ms. Rice, my calculator's not working, I just reset it and then plug it in. They're like, oh my gosh, you fixed it, you're amazing. And I'm like, I know, I am amazing. And all I did was reset it. Honestly, that's how I fix like 99% of the calculator problems I can find. Okay, so our calculators are reset. We're going to go ahead and plug in this equation we can see. And the way you plug an equation, so here, this is the screen we do our calculations on. We're just adding numbers, whatever. To get an equation to graph, we want the y equals screen. And to get that, we use this button right here. If your calculator's newer, you probably still have the button labeled. Mine has scratched off. But the y equals button is right here. So go ahead and click that button, y equals. And this is where you can plug in all your equations. So y equals 2. And now we need the absolute value sign. So to get the absolute value sign, you need to hit the math button. There's your math button right there. So we hit the y equals button, now we're hitting the math button. We go over to the second column where it says number. Second column where it says number, and it is the first one, ABS, absolute value. Everyone got that? Okay, so 2 times the absolute value of x minus 1, the x button is right here. It's x, and then a t, and then a theta, and then a mu, I think that is. We're going to hit this. This is where our variables are. X minus 1. And then we're going to hit a right arrow to get out of that. And then minus pi. The pi is right here above the up arrow button. The up arrow is how you do exponents that are other than a squared. The pi is in blue, so we're going to use the second button to get it. So we're going to hit second, up arrow. Everyone good? All right, what do I need to repeat? Ooh, yes, come sit up here. Want to sit there for a second? John's taking notes, so you can sit up here while I do this part. Yeah? You want to just sit here while we do the calculator part, and then you can sit at your seat again? Okay. Okay, so the buttons that we will be interested in typically when we are graphing is the window button right here. This tells us just how wide and how tall our graph is. So if you hit the window button, usually it's going to go left 10, right 10. It's going by ones. And then it's going to go down 10 and up 10, and it's going by ones. That's what this means. Okay, so that's pretty typical. All the way over here on the right, we're going to hit the graph button just so we can see it. So that was all the way over here on the right. We're hitting the graph button. And you can see it looks about the same. It's a little bit, we're seeing a little bit more because this graph is going to -8 and +8, and our graph went -10 to +10. So we're seeing just a little bit more. Yeah. Okay, so x minus 1 and then minus, and to get the pi in there, minus. Okay, how did I get out of the absolute value? Oh, that's fine. So just do an end parenthesis. Okay, that's yep, and then minus, and then hit second up arrow. Your calculator is on the old operating system, and I can give you an updated operating system. I can like plug your calculator into mine and update your operating system for you. So your calculator is just doing that because it's a little bit older. Okay, so what we're going to do now is we have a menu of different things that you can calculate. So if you look right above the trace button, it says calc in blue. So if we hit second trace, it will take us to the menu of all the things that we can calculate with our calculators. Okay, so second trace. And the first one that we are interested in is number 2 on the list. It is called the 0 of the graph. So we are going to add to our notes here, right above X-Intercept. Another name for X-Intercept is called the 0 of the graph. And that is because the function, which is the y-coordinate, the function equals 0. So they call it the 0 of the graph because the y value is 0, which means the function equals 0. So it's the 0 of the graph. So to get there, I'm just going to write down the calculator instructions that I did. I hit the second button, and then I hit the trace button, and I'm using number 2. Second trace number 2 is how I get the X-intercept on my calculator. Okay, second trace number 2. Now, when you get here, you can hit the number 2 and it will automatically go there, or you can use the arrow buttons and scroll down to number 2 and press enter. Both of those things will achieve the same purpose, okay? Now, when you do this, it's going to start asking you questions. So it's going to ask you for left bound and right bound. You can do your left bound and right bound which is using these arrows to scroll. You can see that I'm moving my cursor left and right. So what the calculator is asking you to do is it says, I'm not very smart. I need you to show me where the x-intercept is, okay? So it needs you to say, the x-intercept is between here and here, the left side and the right side. It needs you to show where you are looking. Does that make sense? So you can use the cursor to move up and down, or you can put in x values that are to the left and to the right of the x-intercept, okay? So you can scroll, you can pick x values. I typically like to just plug x values in because it's faster. Scrolling, having to hold the arrows down, sometimes is time consuming, and I'm lazy. I don't like to sit there and wait, okay? So if I look at this, I can see that the x-intercept is somewhere between -1 and 0. Or if my eyes are not that great, I could say, oh, this x-intercept is somewhere between -5 and +1. You guys see that? Okay, so maybe I don't want to be that specific. So for the left bound, I'm going to say, hey, the left bound, it's between -5. So I literally just started typing and it let me do it. It's somewhere between -5 and I pressed enter after that, -5, and then I press enter, and +1. Now, I'm not going to say, hey, the x-intercept is between -5 and +5 because there are 2 x-intercepts between that left bound and right bound, and that would be very confusing for the calculator. It wouldn't know which one to look for. Does that make sense? So we have to make sure that when we do a left bound and a right bound, you're only getting one x-intercept in between that left bound and right bound. Does that make sense? Okay, so I did -5, I pressed enter, I did +1, and now I'm going to press enter again. It says that it's guessing. I don't want a guess. That's dumb. Whoever wants a guess, nobody wants a guess. So I'm going to press enter again, and I'm going to ignore that answer because it's silly. And then there's my answer. I know that this answer is correct because the y-coordinate is 0, which is how x-intercepts work. The y-coordinate is exactly 0. Okay, how do your brains feel about that? Did you put it in as right bound? Did it say error? There you go. All right, so we've got our first x-intercept is -0.571, 0. And now we have to do it again because we do have a second x-intercept. So this time I'm going to do the left bound and the right bound again. Second trace, number 2. And this time when I do my left bound and right bound, I'm maybe going to say that my left bound is 0. And what could I put for my right bound? +4. Okay, so left bound is 0, and then I'll press enter. And for right bound, I'll put +4. And press enter. I see it says guess ? I don't care about the guess, so I'm going to push enter one more time. And my x-intercept is 2.571. All right. So second trace number 2, that's how we get to the x-intercepts on the calculator. Yeah. Yeah, I always write 3 decimal places just out of habit. I'm going to do 3 decimals unless they say otherwise. That's just a good habit to get into. Good question. Okay, so the way we do x-intercepts, we're going to go to that same menu. So we're going to do second trace. And for this one, we're going to use option number 1. Option number 1 is not specific to y-intercepts. Option number 1 lets you get the x value for any x value that you want, as long as it is an x value that is in the window. So right now I can plug in any x value that's between -10 and 10. So if I do second trace number 1, I could find the y-intercept, but I could also plug in 9, I could plug in -9.9, I could plug in 5, I could plug in pi, I could plug in the square root of 2, I could plug in all sorts of numbers that I want. So for this particular one, if I want the y-intercept, what should I plug in? 0. Okay. So I'm going to plug in 0 for x. -1.142. Right. And then on my notes, I'm going to write second trace number 1, plug in 0. Okay. Does that make sense? Yeah? Okay. So X-intercept, Y-intercept, we're saving ourselves some time. We're not doing that by hand anymore. That's in the past. Until we get to calculus, and then we might have to do it by hand again. Good times. All right. The next word is continuity. So continuity just is whether or not you can, this is an informal definition. You will learn formal definitions later on in math. But you'll know the graph is a continuous curve if you can trace it with your finger without picking up your finger. Okay, so most of the graphs that we are going to deal with this year are pretty, or this semester, are pretty simple graphs, and so most of them are continuous. All right, so this is a V-shaped graph. When I trace it with my finger, I put my finger down, I trace it, I trace the whole thing, and I didn't pick up my finger once. So absolute value functions are always continuous. It doesn't matter what transformations have happened to it, it's always going to be a continuous function. I'm going to draw a little example of a not continuous function so you guys can see what I'm talking about. So we're going to draw it off to the side. We're going to say an example of not continuous is a rational graph. Rational graphs are like 1 over x. You guys did those in math too? Briefly looked at this? Is that right? I taught it and I don't remember either. They look like this. How do I not remember that? Yeah. Perfect. Thank you, sir. They look like this. And so if you, since they have those two curves, if you wanted to trace it, you would trace this piece, and then you come up here, and then to finish tracing the graph, you'd have to pick up your finger and jump down here and then keep tracing. So it would be considered to not be continuous because you have two different pieces to the graph, and you'd have to pick up your finger to jump from one piece to the other. Does that make sense? Okay. So, but for an absolute value function, it's just a v. So you're gonna, you're gonna keep your finger on the paper to trace a v. Okay. The last vocabulary word that we are going to go over for characteristics is end behavior. And end behavior is just the mathematic, like symbolic way of describing the arrows of the graph. So you're just describing what the ends of the graph are doing, but instead of describing it in words, you're going to describe it in math symbols. Okay? So the math symbols always start like this. It says, as x goes to negative infinity, that's how you read it out loud. As x goes to negative infinity, y goes to, and then you would fill in that blank. You would have to say what it does. And then as x goes to positive infinity, y does something, and you would fill in that blank. Okay? Now, it's not as difficult as it looks. It looks really complicated, but it's not complicated at all. Okay? So let's think about our infinities. So if we have an arrow that's going to the left, what kind of infinity is that? That's a negative infinity. Okay. If we have an arrow going up, what kind of infinity is that? It's positive infinity. Okay. If we have an arrow going to the right, what kind of infinity is that? Positive. Okay. And then if we have an arrow going down, what kind of infinity is that? Negative infinity. Okay. So in the math symbols, this infinity over here is the idea of x goes to negative infinity. A left arrow, if you write it symbolically, is left goes to negative infinity. That's what a left arrow is, okay? An up arrow would be y goes to positive infinity. That's what an up arrow is. That's how you write it symbolically. A right arrow would be x goes to positive infinity. And then what do you guys think a down arrow is? Y goes to negative infinity. So all arrows do two things. They either go left or right, and they either go up or down. So we always describe them doing both things, okay? So for this one, we're going to say as x goes to the left, so as we look at the left arrow, we're going to say if it's going up or down. So with this picture, when you look at the left arrow, what is it doing? It goes up. So what would I write next? Y goes to positive infinity. So we would say left arrow goes up. But we just write it symbolically. We write it with math symbols instead of with words. Okay? Over here, we're going to say as x goes to positive infinity. So now we're talking about the right arrow. What does the right arrow do? It goes up. Y goes to positive infinity. So we're saying the right arrow goes up. Does that make sense? So all it is a symbolic way of writing about your arrows. That's all it is. Okay, take a moment and see if you can write out the symbolic way of writing out the arrows for the other one. So we're going to say what the left arrow does, we're going to say what the right arrow does for this picture right here. So as I look at the left arrow, as I look at the right arrow, so how should we finish both of these? Yeah, Gage.
X goes to negative infinity and another step to the left, and then a little dash, and I said y goes to negative infinity and another down.
Perfect. So this is left arrow, and this is, it means down arrow. Perfect. 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 So when we normally put this on math worksheets, when we're writing our answers, you don't actually write the words left down, right down. We're just putting that because these are our notes. So we're making sure our notes make sense. Okay. All right, perfect. So this assignment, these are the notes, but they went with that graphs of absolute value functions assignment. That assignment at this point can be completely finished. So I think that all we had left was like problem 21, and then 28 through 32, I believe, is all we had finished. And at this point, you guys have all the information to be able to do that assignment, okay? All right, so now we're gonna go ahead and get out our video notes from the weekend. And we have to finish example 5 and 6. Not 5 and 6. Yes, 5 and 6. 5 and 6, okay. 5 and 6. Since number 5 is kind of a weird one, let's go ahead and do number 6 first. So, if you look at number 6, what is the vertex for number 6? -8, -3. Okay. And then if we were to graph it, does it go over 1, up 1, over 1, up 1? Or does it go over 1, down 1, over 1, down 1? Does it have a stretch? Does it have a compression? It's a compression. Okay, so it goes, it's upside down. We can tell because of the negative. It's upside down. It's a compression of 1/2. So instead of going over 1, down 1, it's going to go over 1, down 1/2. Over 1, down 1/2. Over 1, down 1/2. Over 1, down 1/2. So that's exactly what you were saying about like over 2, down 1 is kind of what it's doing. Over 1, down 1/2. Okay. So since it's compressed, it has the appearance of being vertically squished, like it's really wide. Okay. So now that we know that information, how do we start writing the piecewise function? Anyone remember from the notes, or can you look back at your previous examples and figure it out? We have to do the left side of the vertex. We have to do the right side of the vertex. We've got the negative version of something. We got the positive version of something. Okay, we do the negative version first. So we've got the negative version of the equation, which has a negative in it as well. So when I do the negative version, which way does my symbol go? Less than. Okay, less than. And then what number do I use? -8. So I use the x coordinate of the vertex. Okay, so the negative version of the function if x is less than -8. Okay, and then what do I do for the second part? The positive version of the equation if x is greater than -8, okay? And then what do I have to make sure I do to one of these symbols? Put an equal to on one of them. Do you guys care which one we do it to? Okay, which one should we do? The bottom one? All right, so now that I've written each of the equations, what should I do? Simplify things? How do I do that? Distribute. So minus minus makes a plus. And then I distribute, take the 1/2, distribute the 1/2. So I get 1/2 x, and then what? I multiplied the 1/2, so I got 1/2 x plus, and then what's my number? Plus 1. If x is less than -8. So the second one is negative 1/2 x. And then what's the number? -7. If x is greater than or equal to -8. Do those linear equations make sense with the picture? Yeah? So if we were to think about these kind of continuing, yeah, there's the plus 1, that fits. And then we could kind of check this one. Yeah, -7, that one fits too. Okay, so number 6 is good. All right, so now we got to do number 5, the weird one. You guys ready? Whew, okay. So before we do the weird one, we're going to do a little reminder off to the side. We're going to remember factoring. Okay, remember factoring. So back in Math 2 and Math 1, if you were factoring a problem, you might have like x plus 8 times x minus 3 equals 0. And if you were solving that, you would have two answers. And if x plus 8 was one of your parentheses, then what would that answer be? You'd say x equals, and x equals, remember this from Math 2? -8 and +3, right? You'd just be like, oh, it's just the opposite sign. You guys remember doing that? And then you might have a problem like x plus 5, and then maybe like 2x minus 1. So this one, what would the first one be? -5. Anyone know what the second one would be? 1/2. So if you had something written like this, that answer would be a fraction. It would be positive 1/2. You guys need me to review how we got those answers from factoring? Would that be good? To just remind you guys where those came from? You can't tell if you're just kind of staring. So the idea that we're looking at today, when we find the x-coordinate of the vertex, it's similar to the idea of factoring. So you guys notice that the x-coordinate of this vertex was -8. Oops, sorry, you can't see. The x-coordinate of this vertex was -8, right? The x-coordinate of this vertex was -1, right? On the front. the x-coordinate of this vertex was positive 5. That's similar. So if we look at a problem like example 5, the x-coordinate of the vertex is not going to be positive 2. It's actually going to be a fraction. It's going to be positive 2/7 because there's a 7 in front of the x. And it comes back to that same idea from factoring, where we have the 1 that's being divided by the 2. So here we have the 2 that's being divided by the 7. Does that make sense? So it's an idea you've done before, it's just in a slightly different context. So this x-coordinate of the vertex is 2/7. Does anyone know what the y-coordinate would be? 0. Okay. Now this one is a little bit harder to graph because it does have a coefficient in front of the x, which we haven't had before. So our regular shortcuts as far as having a stretch or a compression or whatever, they don't work quite like we want them to. So with this one, instead of graphing it and then doing the piecewise function, we're going to go ahead and do the piecewise function first, okay? So we do have this though, but we're going to have to go ahead and just depend on our piecewise function rules to be able to do this problem. Does that sound okay? All right, so how do we start writing the piecewise function? We start with the negative version, so let's go ahead and write that. We have the negative of 7x minus 2, and then there was nothing on the end. And then we say if x is less than, if x is less than what? 2/7, okay? And then what should we write? The positive version. So then we will write 7x minus 2 if x is greater than 2/7. So we did the negative version with the less than, the positive version with the greater than. What am I currently missing? The line, the little line for the equal to. So which one should we put it on this time? The top. All right. Let's go ahead and put a dot for our vertex because we can at least do that. So 2/7, 0, like right in here maybe? Okay. So we have some simplifying to do. How do we do that? Distribute the negative. Okay, so if we distribute the negative, what do we get? Anybody? Negative 7x plus 2, and there's nothing else we can do, right? That's just it. And then the other one is already simplified. It just doesn't really need the parentheses. I'm just going to rewrite it. Okay. All right. Now, if you are writing in pencil or in pen, don't draw this until we've done it in pencil first, okay? So only do this next part if you're writing in pencil because we're going to have to erase a little bit. So this says graph negative 7x plus 2. We're going to graph the line negative 7x plus 2, but only the part of the line that is left of 2/7. Okay, so here's the 2/7. So we have a y-intercept of positive 2. And a slope of down 7, right 1. 1, 2, 3, 4, 5, 6, 7, right 1. Okay. Now, before we think about what part we are supposed to keep of this, ignore what you've drawn and just look at the equation. Tell me, should that V be right side up or upside down? Based on the equation. Should be right side up. So we know that our V should look like this. Does that make sense? Okay. So if we look at our V, it had a very steep slope. It had a slope of 7. It was very steep. And we have our vertex right here and our y-intercept right here. And we know, like on this one, when we checked it, our lines, when we went through our y-intercept, our lines went past the vertex, right? They went a little bit past when we double checked them. But if we had drawn it that way, there's part of the line we would have had to erase, right? So since we're using the lines to help us graph, there's part of the line that we're going to have to erase, okay? Can you guys tell which part of the line shouldn't be there? The bottom part should not be there, okay? So what I'm going to do is I'm going to go back and I'm just going to erase this bottom part. Everything that was past the vertex needs to be gone. I just had to graph it so that I could get my slope, the steepness of my slope, so I could get that correct. I had to graph it. Okay, but this part is correct. It's just like a real steep line. The good news is you're never going to have to graph another one of these, because if you look, the activity we're doing today is around the room. And if you look around the room, the only thing you can see on those pages is the equations. You're not going to see graphs, because for this activity, we're more concerned with you writing the equations than we are with you graphing them. Does that make sense? Because you guys have already spent a whole day graphing these by hand. You know how to graph these by hand. I'm more concerned that you can actually convert the equations. Does that make sense? Okay. All right, let's graph the second one, though. So the second one says a positive slope of 7, a y-intercept of -2. So let's go ahead and graph that one. Y-intercept of -2, positive slope of 7, 1, 2, 3, 4, 5, 6, 7 over 1. Get that steep slope in there. And then can you tell which part should be erased? The bottom part. So we're making a V. This is the right side of the V, right? Because we know that the first part makes the left, the second part makes the right. So we got the left side, the right side of the V. Now, if it's bothering you that your V is not like symmetrical on both sides, you know, like one part of the V is like further up and the other part's not, you can go ahead and just add a little bit more symmetry. That's fine. If it's bothering you. There we go. All right. So we have a very steep absolute value graph because it does have a 7 in the front, which means there is a very steep vertical stretch there. It's a very stretched graph. Whew. Okay, so can we do the big picture perspective of finding the vertex, doing the left side is the negative version, the right side is the positive version? Can we write those? Yeah, we're comfortable with that part. That kind of makes sense. Okay, so the activity for today, you can see we're not doing a worksheet today. We're going to do an activity around the room where you can work with people at your table, or you can work with people at other tables. You can work by yourself. You can work in groups of 2, in groups of 3. It is up to you, okay? So you can work in groups of however many you want to. You're going to do the problems on a separate sheet of notebook paper, and you can start on whatever letter you want to. You do not have to start on a specific letter, okay? Now, when you do the problems, you're going to write the problem down, and you're going to show your work. That is the part of the assignment that you're getting credit for, is writing the problems down, showing your work. Now, you got to be careful when you do it, because some of these problems, since this is an activity that I made for an honors class and not for the regular class, some of the problems are very similar. Like the only difference between them is that one had a negative, one problem had a negative, and the other problem had a positive. So the answers are like super similar to each other, which means that if you are not paying attention, you might accidentally go in the wrong order and get confused and end up doing the same problems twice. Does that make sense? So be very careful to make sure that you're actually looking at the right answer and not like just assuming that it's the right answer because it looks similar, okay? There are 11 problems, I believe, and what ends up happening is you look at a problem, you do the problem, and you get an answer, and then you look for that answer around the room, and that tells you what problem to do next. So that as you do the work, you are basically checking your answers, okay? And that helps me as your teacher because I know that if you successfully finish the assignment and you get the problems in the right order, then you probably understood what you were doing. Does that make sense? And then anyone who is struggling, that gives me time as the teacher to sit down with you one-on-one and help you because everyone else is working and they're fine. They know they're getting the answers right as they go. Make sense? At any point, if you want to check your answers and make sure your order is correct, at any point you can come up to me at my desk and say, Ms. Rice, please check my order and make sure it's correct. And I will make sure that you are going in the right order. Make sense? So 11 problems, start at any problem you want, work with whoever you want. The goal is just to get them done before the period is over, okay? Any questions? Oh, you can go ahead. There are two things. I forgot about that. Thank you. There are two things you are turning in today. One is the absolute value equations worksheet where you did all of the odd problems and you might have done the evens if you wanted extra credit. Yep. The second thing you are turning in is a sheet of notebook paper where you did absolute value inequalities, and you should have done 6 problems on that. Remember, we were working on them in our groups on little slips of paper. Everybody was working in their groups on little slips of paper, and then if you did not get 6 problems done, you were supposed to get on Canvas and find more of the problems to do. So there are 2 pieces of paper that you are contributing to the pile. One is a worksheet, and one is a sheet of notebook paper. Yes. Yes, you will get them back. So you had that. Hold on, let me show you.